So we just saw a geometric non-level annuity, meaning the payments increased by a fixed percentage every time. In this example, it's a non-level annuity, so payments are changing, but they're changing by a fixed amount instead of a fixed percentage. So to find the present value of an annuity immediate for end periods, I just want to draw what the timeline would look like. So you're paying P dollars here, and this would be P plus Q, P plus 2Q, and so on, however many you had. So if there's end periods, it'd be P, this is 0, 1. So it'd be P plus N minus 1Q. And I'm not going to derive this. We'll go through an example of how you would do the derivation through an example instead of with the P's and Q's. So I just want to at least provide you with the formula and the notation that go with this. So because this is an increasing annuity, in order for the payments to get bigger, I'm using an I, so it's I sub P comma Q, P meaning your initial amount, Q meaning the amount you add every time. A N I. So this is the present value of an increasing annuity. So there's the formula for an present value of an increasing annuity. And just so we have it, let's do it for perpetuity also. Is P over I plus Q over I squared. Alright, so let's look at an example. So find the present value of a perpetuity immediate whose successive payments are 1, 2, 3, so on. So we're adding 1 each time. So our Q is 1, if we're thinking about the formula, and our P is also 1. So because it's a perpetuity immediate, this I sub PQ, find the present value. We know it's 1 over I plus 1 over 0.05 squared, and we'll get 420. So that's pretty quick if you know that formula. I just want to go through kind of how you would derive the formula, and you can choose to ignore it. Alright, so I'm going to say the present value, I'm going to call it PV, is 1 V, because you're bringing back the 1. So bringing back that 1. Now bring back the 2, so plus 2V squared plus 3V cubed plus ... Now I'm going to multiply my present value times 1 plus I. And when I do that, I get 1 plus 2V plus 3V squared plus ... And now I'm going to subtract these, or I'm going to negate this one and add it to this one. So I'll have present value times 1 plus I minus the present value equals 1. And then I'm going to subtract these two, so I'll get V, then subtract these two, I'll get V squared, and so on. So notice now I have a geometric series. So the left side, this PV 1 plus I minus PV, is really just the present value times I. And the geometric series formula is 1 over 1 minus V, because it's infinite. And so now I know my present value is 1 divided by 1 minus V times I. And you can simplify that if you want. If you do a couple steps, you can get 1 over I minus D, and you get 420. And that D is your discount rate. Or you can just plug this 1 over 1 minus I over 1 plus I times I, whichever way. Either way, you get 420, which is what we got using the formula also. But this technique of multiplying the present value by 1 plus I and then subtracting is how you would derive the formulas for an increasing annuity, where increasing we mean increasing by a fixed amount each time.